There's this surprisingly passionate debate happening right where math and computer science crash into each other. It's basically a fight over a couple of symbols, but it digs into something really fundamental, how we think about the flow of information itself. So, let's dive in.
And it all kicks off with a feeling I think we've all had, summed up perfectly by this Redditor, M for Embo. You're reading along, everything's making sense, and then bam! You hit a formula that you have to read backwards. It just feels unnatural, right?
And right here, this is the heart of the whole issue. We see a process that clearly flows from left to right. X goes into function f, that result goes into function g, and boom, you get z. Super simple. But the old school math way to write this is g composed with f. The symbols are literally the reverse of the diagram. So why?
Okay, so to really get to the bottom of this, we've got to make sure we're all on the same page about what's actually happening here. The process itself is called function composition.
The easiest way to think about it is like a little assembly line. Whatever comes out of one machine becomes the exact thing that goes into the next machine. It's a fundamental idea, whether you're doing calculus or coding an app.
All right, let's actually walk through this assembly line step by step. You start with your raw material. We'll call it x. It goes into the first machine, function f, and what comes out is f of x. Now, that piece doesn't just sit there. It goes immediately into the second machine, function g, and the final product that rolls off the line is g of f of x. Makes perfect sense, right? The real question is, what's the best way to write that down?
And that brings us to the two competing ways of writing this all down. This isn't just about picking symbols. It's about two totally different philosophies. It's time to meet the two teams in this fight.
So on one side, you've got team composition, the traditional math approach with g of f. You read it as g of f, and the whole point is that it puts the final function, the last step, right up front. Then you've got team pipe, which is huge in programming. They write it f pipe to g. This reads exactly how you'd think, f then g. It's all about the flow of data from left to right, just like that diagram we saw.
So who cares? I mean, they're just symbols, right? Well, turns out this choice actually matters a ton. From the deep foundations of calculus all the way to how we build the software we use every single day. This is way more than just a style preference.
So let's start with the mathematicians. Why on earth do they insist on writing it in a way that feels backwards? Well, there's a really, really good reason, and it's perfectly designed for one of the most important tools in calculus.
And check out this brilliant analogy to explain it. You don't need any math background for this. If a car is twice as fast as a bike, and the bike is 4 times as fast as a person walking, how much faster is the car than the person? Well, you just multiply them. 2 times 4 is 8. It's completely intuitive. That core idea is what's behind something called the chain rule.
And here it is, the formal chain rule. Okay, I know, it might look a little intimidating with all the apostrophes, but just look at the structure, f of g of x. That right-to-left, inside-out structure is exactly what mathematicians are working with. The notation is literally built for this specific tool. For that kind of abstract work, that consistency is king.
All right, so that's team math. But programmers? Programmers have pretty much staged a rebellion and gone the other way. And for them, the priority isn't some abstract proof. It's about building and, more importantly, maintaining software that actually works. And as the programmer Ahmad Hawash says here, it all comes down to being natural and easy to read. When you're staring at hundreds of lines of code trying to figure out what's going on, you want to read it in the order the computer is actually going to run it. The pipe operator lets you do exactly that.
And wow, this example says it all. On the left, you have a price calculator that's just one giant, unreadable formula. Good luck finding a bug in there. But on the right, you have the exact same logic using a pipe. It's beautiful! You can just read it like a story. Take a price, then apply a % coupon, then apply a discount, then shipping, and so on. Every single step is its own little function you can easily test. It's cleaner, safer, and just makes sense. This is why programmers get so excited about this stuff.
So after all that, who wins the fight? Team math or team code? Well, the truth is, neither of them are wrong. They're just using specialized tools for completely different jobs. It really boils down to this. When you're a mathematician doing a proof, you often care most about the properties of the final function in the chain, the g and g of f of x. So it makes total sense to put it first. But when you're a programmer, you care about the step-by-step journey the data is taking. You want to follow it from start to finish, so a left-to-right sequence is just way more intuitive.
See, it was never really about one way being backwards. It was always about perspective. It's about what you need to see first, the final destination or the first step of the journey.
Both are totally valid ways of looking at the same process.
And that just leaves us with this really cool thought. The symbols we choose aren't just random rules. They actually shape the way we approach problems. And it kind of makes you wonder, doesn't it? What other symbols do we use every single day without ever stopping to think about the why that's baked right into their design?